Welcome to the Coldworking Shop. In today's video, I'm going to be lapping, grinding, polishing, and completing the work on the Damascus chip stack marine project that I stacked together in the last video and constructed in the previous videos. The first step in the process is going to be to manually, without any assistance, grind enough of the surface flat that it'll stick to my suction cup, and then I'll proceed to use my suction cup rotating fixture device and see if I can make this process a little bit less annoying. So I'm starting off with an 80 grit diamond wheel. That's a metallic wheel with diamond coating. The lap wheel is another one of my designs that I made in the shop. It has center feed water that I find very convenient. I'm wearing gloves to avoid grinding the end off my finger, and it's kind of hard to pick up a piece with gloves on. I think that I may actually have a good enough surface here. Okay, so I've got the vacuum pump, the water separator. Vacuum is holding. My fixture has an indexing head, so I can rotate it back around here. And this is still an early prototype, so the connection is not that good. Eventually I'm going to come up with something really nice, but in the very early stages of testing, it's still a tiny bit crude. So we are rotating, and now I cast up a 5-pound lead block to apply a little bit of force. I'm not exactly sure how long to do this for, so I'm just going to do it for a while with the stopwatch on, take it off, observe the results, and hopefully kind of like come up with a set of procedures so that I'll know in the future exactly how long to do each step. The surface that I made using on the graphite plate, using the paddle with hot working, the surface is pretty good, and so I don't need to do a tremendous lot of rough grinding, but there is a bit to do. Got to get it flat with the coarse wheel, and I'm looking over here at the stopwatch. That's 1 minute. So let's over here, rotate around, and kind of take a look at the surface and just see, is it flat yet? Not quite. It still has a little divot in the center, but exceptionally good progress is being made. I think this is going to be a very successful machine here. really need to fix, or actually not fix, just I really need to design a better connection. That connection is pretty darn awful. So give it another minute. Watching carefully to see what's going on. I made this weight by casting lead into a piece of 1.5 square tube, 1.5 16th wall square tube, and then made a little bracket with a pin to keep it aligned. And it seems to be reasonable. I just guessed at 5 pounds being sufficient, and may actually be. Of course, this is a very early prototype in early testing, so the details are not fully worked out. Still has a tiny divot in the center. I try as much as I can, I try to get the piece as flat as possible. Let me go get my apron. Coldworking can be messy. I try to make the piece as flat as I can in the hot working, but for one reason or another, I ended up with a little bit more of a divot in the center of this piece, more than I would have liked. I believe that it's still going to come out being a successful piece, but it will require a little bit more rough grinding to get it under control. So I think I'm going to give it 2 minutes just to work on that divot, but overall the process seems to be working extremely smoothly. I've got no chatter, no vibration, nothing appears to be going out of control. I'm using a fairly small amount. I don't know if you can see here on the video, probably. Using a fairly small amount of water in the center feed. I want to have enough water to cool the piece and wash away the swarf, but I don't want to have an excessive amount of water that leads to hydroplaning and kind of prevents any cutting from happening. So I think this is a reasonable amount of water, and almost coming up on 2 minutes, and then we will see if that takes care of it. The weight seems to be working well. The indexing head seems to be working well. Yeah, still got, like I said, this amount of divot that I have on this side in the center is abnormally large. In fact, out of all of these chip stacks that I've put together this way, this is the only one so far that's had an abnormally large divot in the center. Usually I see them while I'm hot working and manage to get them flatter, but hey, this one just It sneaked past me. But it's always nice to have a plan B. It's always nice to have an option. It looks like the water separator is remaining empty. When I first tried this method of using a suction cup and a vacuum pump, everything seemed to be going really well. I had no water separator. I made several very successful pieces with no problem at all. And then I made one that unfortunately had holes in it. And it was just due to the fact that I used a sensitive color of glass, and in the process of making the thing ended up boiling the glass and ended up with holes in my murrine. And sure enough, it sucked the water directly into the vacuum pump, turned the oil into a really ugly, disgusting foam that pooped out of the top of the vacuum pump. And that's when I decided, gotta be extra careful, you never can tell. And so the water separator is now in place, and if any of my future pieces end up having a leak or holes in them or whatever, and the water won't get into the vacuum pump. I'm using a El Cheapo Harbor Freight vacuum pump that, good enough, does the job. Okay, hopefully the other side will go a lot faster. And old guy, bad eyes. Yeah, still needs a little more. I don't think anybody likes cold working. I think cold working may be the least popular of all of the glassworking operations. And I know I don't like it. I especially dislike it after finishing up a long cold working session and not really noticing anything, and then later on that day discovering that, why is the tip of my finger red? Cold work, unfortunately, is one of those processes where, because it's cold, because it's wet, because the damage happens so slowly, you don't even notice that you're grinding the end of your finger off. I think probably everybody that's cold worked glass has at least one story about a bloody fingertip after a long session. So far I am very happy with this prototype. The sideways drift is somewhat surprising to me. When I started the process, the drift was toward the center. Now it appears to be drifting out toward the edge. When it was drifting toward the center, I improvised this little quick and dirty hook to keep it from going over center, which bad things happen if it goes over center. And now, as the grinding proceeds, it's drifting toward the outside. Not sure I fully understand this. Okay. There's another 2 minutes. That's looking very good. I think one more grinding session. And the divot will be corrected. The rotating head is mounted on a kind of a universal fixture that I'm developing for a variety of different uses. It's got an indexing head that has the same number and angle of positions as the squeezer, so I can do 2, 4, 3, and 6 positions of indexing, then connected to a standard ER20 collet, and that means that I can put a variety of different things into the indexing head, including a clamp device for precisely grinding the hexagon flats around the edge of this piece and make a really nice precise hexagon that fits into the stand, the sculpture that I'm going to be making for it. It also, if you don't put the indexing pin in and put a cordless drill out here and clamp it into the holding fixture, you can rotate around and get a precise circle for my circular pieces. Of course, this design is somewhat a kind of somewhat simplified faceting head, and with the addition of another axis and a little bit more precision, this machine can do full faceting. Not sure that any of my projects in the future call for faceting, but my overall goal in this whole glassworking adventure is to continue making increasingly precise geometric patterns using a combination of handwork, machine work, and possibly even a bit of CNC. Oh, now that, boy oh boy, that is looking very nice. So here's that side. Good thing I made the piece a little bit thicker than the final design. I cut the chips, and I'm having a little bit of weird problem here. I cut the chips a little over 1/4 inch thick. So that I would have a little bit of extra wiggle room just in case. And now it definitely is drifting toward the outside as I start working on the other side, on the better side that doesn't have the divot. And this one's going to require a lot less grinding. My target was to get somewhere between 150 and 200 thousandths, 0.15 and 0.2 inches of final result. And I believe that I'll come out just fine on this piece, but that's the reason that I go for a little bit thicker set of chips to start with, is to have that little bit of kind of safety margin in case something goes wrong and I need to fix it in cold work. Of course, if I really wanted to go crazy, I could make the thing a 1/2 inch thick, but there's always a trade-off. The thicker I make the chips, the less chips I get from a pull. And as I said in a previous video, a lot of the geometry follows from the earlier steps. When the squeezer dies are 4 inches tall, and a 4-inch piece is about the biggest that I can manage, single-ended on the Inquala. Anything more than 4 inches just becomes unmanageable. And so I start with a 4-inch core, and then by the time that everything is assembled and pulled down, I usually like to get somewhere between 7 and 8 inches of usable material. My kiln is only a 12-inch kiln, so I kind of, even if I had the ability to pull a 20-inch piece, it wouldn't fit. So I end up with somewhere between a 7 and 8-inch piece, which is cut into chips, and then I use that to make as many of the chip stacks as I can. In my last, in the piece that I made in this set of videos, I ended up with enough chips to make 3 pieces. And hopefully all 3 of them will end up polished up and nice, and I'll have 3 successful sculptures when I'm finished. Okay, coming up on time. And there we have our time, and I'm going to probably make a little plastic enclosure for the motor. Nope. Getting close, and I still have decent thickness. I'm not running into a problem. I'm still about 0.2 inches, so grind away a little bit more. This fixture it was made on the CNC machines, and so it has pretty good tolerance. It doesn't have dialed in machine shop tolerance at the end, but it has pretty good squareness and perpendicularity and rigidity. If this prototype turns out to be very successful, I may just call the design finished. If I run into any problems where I need increased precision, then I'll put the extra effort into trying to dial it in down to the 1,000th. I suspect that this guy is probably accurate to within 5 or 10 thousandths, although I haven't gotten out the indicator and measured it. I was just kind of like hot to trot to see if the prototype worked, and just put it on and watched it work. I'm feeling a tiny bit of vibration, but I believe that's just because I stuck the wheel down a little off center. But just in general, except for having to babysit the drift, it seems to be working exceptionally well. Okay, weight off. Rotate into position. I'm a little bit, as I work on this thing, it's still got a low side on one of the outer sides. The center looks beautiful. I'm really happy with the way this guy is coming out, but so what I'm wondering is this, now having limited experience here, does it just cut slow by its nature? Is cold working just naturally slow? Or if I had the proper combination of setup and parameters and maybe more weight or different speeds, different water flow, would I be getting a better cutting rate? But then again, this piece is over 3 inches across the flats of the hex, and it's easy to imagine that when you have a fairly large amount of surface area and the diamonds are very small and they load up with swarf almost immediately, and so it probably isn't cutting over the entire surface. There's probably a bit of dragging going on, although I don't know enough about diamond lapping to know for sure. But one thing I can say for sure, I'm glad I'm not doing it by hand. It'd be nice to refine this process to the point where I could just walk away. Of course, you know, there's always the danger of, well, what if I did walk away and forget about it? Grind it down to nothing. The vacuum pump, suction, and O-ring holding method is working exceptionally well. The piece is secure, it's not slipping, and as far as I can tell, is producing a nice parallel result. So I believe that I can call that design a success. Yeah, I don't know. I've got a low corner on the hex. I don't know how far I really want to grind it down. This is a fairly boring process, and even with my hopefully interesting commentary, it's unlikely that anybody would really enjoy watching the entire process. But this does bring up a philosophical question about making glassworking videos. Do you show it in real time, or do you edit? Do you speed it up? What is it for? Is it for education, or is it for entertainment? And when I was starting glasswork, when I was in the very first weeks of glasswork, I was watching a lot of YouTube videos that were sped up, edited, and as I was trying to learn the timing, you know, how long is that piece in the flame before it gets workable? How long does it take to do this operation? How long do you heat it before blowing? How many puffs do you take to blow out the bubble, and how much is blown out with each puff? Learning timing for the beginner is really, really important. And so my plan is to post all of my videos in real time, boring as they may be, and then at the end of a project, I put together what's called the summary and analysis video that is the entire project sped up, heavily edited, with hopefully insightful commentary for those who don't really need to spend a lot of time learning timing, but instead just want to see, well, how do you do it? What were the steps? Yeah. One more. And then, after the rough grinding is done, I'm going to proceed through the grits. In woodworking, which I'm much more familiar with, I've been woodworking since I was 7 years old. In woodworking, it's common to just progress through the grits while sanding. Progress one grade at a time, one after another, until you finally achieve your final finish. In glassworking, I've heard different opinions from different glassworkers. I currently have, let me see if I can remember all of these. I got some of it written down on the wall, but some of it just from memory. I've got an 80, a 100, and a 220 metal wheel, and then a 220, a 325, and a 600 resin bond, what they call a polishing wheel, or I think it's a polishing wheel. And then the last step is cerium oxide on a felt wheel. And I usually go through, based on my woodworking experience, I usually go through the entire set of grits. In talking with other glass workers, some of them agree. Some of them think I need more grits. I need more intermediate sections, and others use a smaller number of steps. Some go from saw cut to 325 wheel direct to cerium. I'm still experimenting. Of course, if anybody out there wants to give me any pointers, give me, the benefit of their experience, by all means, leave a comment. Comments are always welcome. I always love to learn. So, I believe this is going to be, yes. This is going to be maybe I should put a brake on this thing. Got an idea for another I always have ideas for projects. Every time I'm out working, I'm always thinking about what's the next thing I can invent. And of course, I did build this storage unit here for my lap wheels. I'm a maker. I like making my own stuff. I probably won't offer this as a commercial product, but I do enjoy making my own tools. As far as the products that I sell, at the moment, it's just the Inquala. I've been asked, hey, when are you going to start selling lap wheels? And the answer is, I don't know, maybe never. There are a number of companies out there that make quite nice lap wheels. There are no other companies making Inqualas. And so there is a good reason for me to make that a commercial product. As far as a lap wheel goes, there's many, many options. Well, not many, many, but there are many options out there. And I don't know, maybe. Maybe the combination of the rotating head, the indexing head, whatever the various different precision jigs and fixtures evolve into, who knows, maybe someday that'll be a product that's unique enough that it makes me think, yeah, maybe I'll produce that. Same thing goes for my wet saw. I made one for myself because I'm a maker. I make things. I like making things. Am I going to sell them? I don't know. Maybe, maybe not. At the moment, I'm leaning toward not. But never say never. As I progress up the grits, I believe that my polishing time on each grit is going to become less. And so I'm going to just, wild ass guess, gonna guess 2 minutes aside every grit up to the cerium. Cerium usually takes a little longer. Oh, that's what I get for talking and not paying attention to the work. Forgot to put the weight on. Of course, I have no idea. The fixture itself has weight, so some grinding did occur, and how to correctly adjust the time to end up with the result I'm looking for. And continuing along, in addition to practicing and perfecting my glasswork, I'm also practicing and perfecting my video making and adding new equipment. I just got a little GoPro, which is the camera that's doing the wide shot in this video. Unfortunately, the GoPro doesn't normally work with an external microphone, so I had to get a big ugly dongle for that to work with the external microphone. And then I've got 3 El Cheapo Canon camcorders and a rather nice Sony still camera that does video, but really it's kind of annoying the way it does it. It's not really a video camera, it's a still camera that does video. So there's my polish. Got a kind of a weird, my motor has a bit of a weird behavior. When I turn off the outlet strip, the motor doesn't want to restart. Odd, odd, odd. So, this is the first actual use of this tool on a piece that I care about, on a piece that I'm actually going to make into one of my sculptures. The first test video, I used a kind of a cut-off end that may or may not be nice enough to do anything with. It was a piece of what was probably pretty decent murrine, but it was the cut-off end and it had some problems. And the problems, of course, I learned from, and it led me to change my procedure in making these things. So I've also heard various opinions on, do you dress a lap disc to dress or not to dress a lap disc? And I don't know. Maybe I should contact the manufacturer of these discs and ask the question. So I'm running out of things to say. In the radio business, they call it dead air. They teach the disc jockeys, I don't ever want to see that VU meter needle down at the zero. Of course, that was back when VU meters used to have needles, back in the analog electronic days. Okay, so we have now completed the second grit. And I'm going to be moving to the finest of the metal wheels. Yeah, I really need to make a little covering. I don't like that little motor being open like that. It's only a 12-volt motor, so I'm not in danger of electric shock, but I certainly don't want to get water or glass dust in the motor. I do have a 3D printer, as well as the ability to machine Delrin, so probably end up either making a little 3D printed hat with a toggle switch on it, or a 3D printed. I'm not that excited about 3D printing. It works, but the parts that result from it really aren't that great. I kind of prefer machined Delrin, but possibly for this application, the 3D printed part would be just fine. For some reason, this grit is really drifting toward the outside of the wheel a lot, causing me to have to babysit it more than I would like, but all part of a learning process, all part of prototype evaluation. And of course, that's what makes this adventure so much fun. Not only am I learning glasswork and making cool stuff, but I'm inventing, testing prototypes, and just having a good old time. Well, hopefully with any luck, this video won't be too horribly long. The GoPro and the Canon are operating on batteries, and they do have a limited amount of time that they'll stay running. check when I release the vacuum, always be very careful before turning it over. After all this work, I would sure hate the glass piece to fall out and break itself. It's interesting, as I'm babysitting it, I'm feeling it kind of pull itself in, push itself out. There are some interesting forces going on here. Probably if I made a kind of a keeper that prevented it from going to the extreme, but then let it waddle around as much as it wanted, as much as it felt like, I might get more uniform wear on my diamond wheels and a better overall result. So that's going to be my next. And then of course the whatever keeper I make has to be quick disconnect so that I can quickly pick it up and turn it over without having to go through a long setup process. So I'm constantly thinking of ideas. Every time I'm on the torch, I'm thinking about new techniques, new machines, new ideas. And of course, if the battery on the camera runs out before the polishing is complete, pretty sure everybody will get the idea what's going on. I don't think there's going to be any real mystery about, oh, I missed it, I wonder what happened, I wonder how it came out. So now I'm going to the 220 finishing pad, and I've actually been warned that metal pads can have problems, what's called rogue diamonds. And so even though you think you have a 220 finish on a metal pad, you'll end up with one pesky diamond in the wrong place that produces a scratch. So that's why I'm going from a 220 metal to a 220 polishing. And if I was gonna change my procedure, I'd probably eliminate the 220 metal. And for pieces that needed roughing, go from 80 to 100 and then 220 on the finishing. And for pieces that didn't need roughing, go from 100 metal to 220. Of course, another question that I don't know the answer to is, what happens to these pads as they age? Should I be keeping a log of how many hours each pad has and be adjusting my timing based on the amount of hours? Should I either develop a better eye or just learn the trick or get better glasses and learn to see the scratches? In woodworking, it's fairly easy to see that you've sanded away the previous layer of scratches. In glassworking, in coldworking, I haven't yet been able to look at a piece of cold work glass and accurately determine if I've polished it far enough. So many things to learn, so many questions. Yeah, that surface is actually looking very nice. I am checking to see that it's securely fastened before rotating, plugging in my completely horrid and inadequate, calling it Rube Goldberg would be a insult to Rube Goldberg. Definitely need to get that under control. But for today's work, I'll make it work. Yeah, it's interesting. Now it's oscillating on its own. If that was repeatable, that would be the perfect motion. But so far it appears to be random and unpredictable, that sometimes they drift to the inside, sometimes they drift to the outside, sometimes they don't drift. I'm also wondering if reversing the direction of rotation, I just guessed at the direction here, but I'm wondering if reversing the direction would make more sense. And I'm looking at the little red lights on the cameras, and I'm still recording. Okay, so now the amount of oscillation has reduced a little bit, and I have no doubt that as I continue this process, I'm going to refine and perfect it and hopefully speed it up a little bit. And even with the automation, it'd be nice to get it done faster. Okay, now that oscillation has disappeared. Switching to the 325 pad. I'm going to be following up this video with the construction of the base for this sculpture, the wood and metal components of the base. I'm planning a fairly ambitious bent and laminated wood construction. I've done quite a lot of bent and laminated wood throughout the years. In the 70s, I used to have a custom manufacturing company that made custom wood products, and I specialized in bent and laminated wood. And other woodworkers would look at my stuff and go, how'd he do that? So hopefully I can put some of those skills to work in my next sculptures and the sculptures after that. I'm also open to collaborating with other glassworkers. I've kind of been somewhat talking to, I don't have a definite schedule yet, but somewhat talking to some of my teachers about doing a collaboration glass, metal, and wood sculpture using their glasswork. And I'm kind of looking forward to that. I think that might be fun. I've also talked to other glassworkers about doing a collab where they take some of my murrine pieces, some of my chip stacks, some of my pulled pieces, and give them to the other guys and make a pipe out of it or something. Most of the people I know are pipe makers, but you know, there is more to glass than pipes. Nothing wrong with pipes, of course. Pipe is a useful tool. When you need a pipe, it's good to have a pipe. And some of the, check to make sure that I'm all, oh, the thickness looks beautiful. I do not have a thickness problem. The thickness looks almost perfect. I personally have no interest in making pipes and will not make pipes, but boy, there are some beautiful pipes out there. The pipe makers have turned what at one time was a utilitarian object into a piece of fine art. And they have pretty, you know, just nothing but my greatest respect. I hope I have enough cerium. I might have to go mix up another batch. So I'm on the last side of 325 before I end up with 600. I've been advised that well before polishing with cerium, maybe you should go to 1200. And maybe I will someday. Huh. Yeah, that connection is just, I think I might have a little bit of water. Try a different power supply. The power supply that I chose was a somewhat underpowered supply that actually appeared to work correctly. Something is definitely wrong here. But hey, that's what prototypes are all about. That is what prototypes are all about. getting what appears to be a problem here. Be getting binding there's a chance I'm just using bronze bushings and not ball bearings. Boy, this connector very definitely needs an upgrade. Of course, I could call it a Mickey Mouse design, but since I used to work for Disney, I'm not sure I want to insult Mickey. Had some good times working at the Mouse. Of course, after this piece is polished, I'm going to take the thing back in the shop, disassemble it, and see if I can troubleshoot what's going on. But hey, welcome to the world of R&D. And no, I'm not shy about showing my prototypes when they don't work. It's a part of history. Next time I show it, it'll be one step closer to perfect. Yeah, it's interesting why it starts and stops like that. It seems to be doing it on a kind of a regular pattern. And no idea why. Oh yeah. It could be a little, I don't know, thinking maybe I might have a tiny little set screw. The little tooth pulleys that I'm using are really tiny and the set screws are tiny, and maybe I need to put a flat or a dimple on the shaft. Maybe the set screws are slipping, but hey, bet I'm gonna get this one done. And there we go. I did build my suction cups with a rim around the outside so that if the vacuum failed, it would still keep the piece from completely going out of control and flying loose. I know that cerium has a higher friction, and always concerned about a suction cup holding during the cerium operation. But things seem to be going reasonably well. Camera's still running. It's always annoying when I get finished with a glassworking operation and then go to look at the video and find out, oh, that camera stopped. Oh, that camera moved. Oh, that piece, that work that I'm doing isn't in frame. Oh, it's out of focus. The exposure is wrong. Oh. When I'm the camera operator doing videos of other glass workers, no problem. Just get the job done. Sometimes I kind of wonder, should I just go down to the local community college and see if they have any photography students or filmmaking students or video production students who might want to join this crazy adventure. Held in place. that is all the cerium that I have mixed up out here. With any luck, it should be enough. Hey, if there's an award for the most boring video on YouTube, I might just be in the running. And that, hopefully, with any luck, completes the operation. So, oh yeah, just about the perfect thickness. And oh yeah, I have got a shine. I believe this was successful. So I'm gonna turn the cameras off, get the batteries, well, put new batteries in, make sure everything recorded okay, and then in the next step, I'm gonna be perfecting the hexagon. So there's more to come. So the next step is going to be to perfect the hexagon using the indexing head with the suction cup on the end. First thing I need to do is just kind of look at it and see which is going to be my reference surface, which is the better of the surfaces. Then align it correctly. So putting it on the reference surface, it's now securely held in place with the suction cup. I'm going to use the finer grit metal wheel because this, first of all, it's on an edge, and second of all, and because it's on an edge, it's going to grind more effectively because there's not as much surface area for the swarf to have to run over. So just by the geometric nature of it, it's going to grind more effectively. And second of all, I don't have that much to grind off. So this is the first test of the indexing head perfecting the hexagon shape. So raise up, index over 1 increment, the triangles were sized on the squeezer fairly accurately. Then they were assembled in the assembly fixture also fairly accurately, but you know, none of this stuff works with machine shop precision, so I have to kind of decide of the imperfect inner pattern, how do I grind a more perfect outer pattern and still have it look like it matches. And I suspect that it'll take multiple passes, but at least just first assessment here, things are looking quite nice. Although look at the pattern again. I might want to do a tiny bit of, yes, I think I do want to do a tiny bit of adjustment here. And also keep in mind, this is the first use of this tool. That side looks fairly reasonable. This is the first use of the tool, and so I'm still developing the procedure. And I can already see that very possibly here a micrometer adjustment. Oh, now the front and back side are not identical. Of course, when dealing with glass, it's probably real easy to drive myself crazy trying to achieve perfection that I'm not going to achieve, so always have to be on the lookout for that. Yes, I do believe that the initial alignment is going to be the most challenging part of this project, of this process. But like I said, it's R&D. Definitely convincing myself that a micrometer alignment will be very beneficial in the next generation. Yes. Welcome to the world of R&D. It may not. The inner pattern may be sufficiently distorted that it may be impossible to achieve the perfect hexagon that I'm looking for. But it appears that the operation of the indexing head is excellent. Suction cup is holding. Movement is smooth. The only problem that I have is that my glass is imperfect, and I've got to try to decide do I want a perfect hexagon surrounding an imperfect inner shape, or should I just abandon my quest for a more perfect hexagon? The sculpture base that I'm going to be using for this does not require an absolutely perfect hexagon. It'd be nice. Of course, I love things that are the more precise, the more perfect, the better. But if this ends up not achieving the perfection that I hoped for, the sculpture will still be a success and it'll still look good. So my overall assessment, my judgment is the indexing head grinding fixture works perfectly. The process of mounting the piece and determining where to grind if the inner pattern is imperfect, the process requires more work. So I'm not going to polish the outside edge to a mirror finish. Doesn't need to be. Just gonna give it a rub on the 600. And call it macaroni. I'm really interested in getting to work on the wood and metal components. I think they're going to be really spectacular, going to be some of the finest that I've ever done. What I may possibly do on the next one of these, I may make a printed paper template that I put on top of the glass before starting the grinding process to assist in correct alignment, so I can figure out where it is that I want to compromise with an imperfect inner shape. And then, of course, as my glasswork improves, the inner shape may get more perfect. And the whole issue of how do I deal with imperfection may diminish. But like I said in the earlier sections, in the earlier videos, my ultimate goal in my glassworking adventure is to continue increasing precision and see if I can make the most precise murrine patterns that I can make, hopefully someday achieving machine shop precision, being able to make patterns within thousandths. And who knows, maybe that's just a pipe dream. Maybe glass will always be a little imperfect. But still, it doesn't hurt to have a goal. But the suction cup is working beautifully. It is spraying a little bit of water on my foot, which is slightly annoying, but everything about cold work is slightly annoying. I'm being very careful. My attachment to the vacuum pump hose does not have a swivel, and so I'm twisting the hose, being very, very careful to not let the hose come unscrewed. Because if the hose came unscrewed, I'd lose vacuum and my piece would go flying, and I'd have a really unhappy day in the cold working shop. You know what? I'm going to call that good enough. I don't know if you can see it in the camera here. The lighting isn't really that excellent, but I'm going to call that close enough. Thanks for watching. It's been fun.